7.5, exponential and logarithmic equations. Any equation that contains the form b to the cx power, such as a equals b to the cx, where the exponent includes a variable, is an exponential equation. We can use logarithms to solve exponential equations, and you can use exponents to solve logarithmic equations. So let's just look at this first one, solving an exponential equation through the use of a common base. So it says, what is the solution to 16 to the 3x power equals 8? So we've got 16 to the 3x power equals 8. The first thing we want to do is, let's see if we can't write this 16 and the 8 so that way they're exponents with the same base. Well, I know that in this case, 2 to the 4th power is 16. So let's say I have 2 to the 4th power to the 3x power, and then 8, well, I know that's 2 to the 3rd power. What we can do now is these two are going to multiply together. So that's 2 to the 12x power equals 2 to the 3rd. And since these two numbers have the same base, it also means that their exponent should be equal. So that means 12x should equal 3. So we can just get rid of the bases. Then we'll solve. So we'll divide by 12 on both sides. And we're going to get x to equal, well, 1/4. Here we're going to do the same thing. So let's see, we've got 27 to the 3x power equals 81. Let's see if we can't write these so that way they're dealing with the same base. So we'll write exponents dealing with the same base. Well, this would be 3 to the 3rd power. And then 81, well, that would be 3 to the 4th power. We'll go ahead and multiply these together. So that's 3 to the 9x power equals 3 to the 4th. Since they have the same base, we can kind of just ignore those. We get 9x equals 4. We'll divide by 9, and we get x equals 4/9. So when our bases are not the same, you can solve an exponential equation by taking the logarithm of each side of the equation. If m and n are positive and m equals n, then the log of m equals the log of n. So let's just try this out. It says, what is the solution to 15x to the 3rd equals 285? In this case, I couldn't figure out a way to make 15 and 285 have an exponential with the same base. So now I'm going to have to use logs. So we'll go ahead and write this as the log of 15 to the 3x power equals the log of 285. And keep in mind, this common base here, we can go ahead and rewrite the left as 3x times the log of 15 equals the log of 285. So now what we want to do is we want to get x all alone. So to do that, we're going to divide by 3 log of 15. And we'll divide both sides by 3 log of 15. We're going to go ahead and put this in our calculator. And we should get x to be right around let's say 0.696. Or if you want to round to 0.7, that's okay. Here it says, what is the solution to 5 to the 2x equals 30? So once again, we can't get them with the same base, so we'll use logs. So the log of 5 to the 2x power equals the log of 130. Go ahead and rewrite the left. So 2x times the log of 5 equals the log of 130. Well, same idea as the last one. We want to get x alone, so we'll divide by 2 log of 5 on both sides. Oops, 2 log of 5. This is what we need to put in our calculator. So in this case, x equals 1.512, roughly. So here we're talking about solving an exponential equation with a graph or table. So let's just look at method 1 using a graph. So on the y equal line, we're going to put 4 to the 3x power. On the y2 line, since it's equal to 6,000, we'll put 6,000 here. All right, and so the goal here is to see the points of intersection. So since we're solving this graphically, we're looking for the point of intersection. So we're going to look, and we'll hit graph. Well, let's hit zoom 6, just so our, oh, wrong button. Sorry, zoom 6, there we go. There's our graph. I can't see the other line, so I can't see the points of intersection, so I need to change my window. So let's just go to the window. Let's change this to, let's do -5. Let's do 6. Let's do y min, we'll do -500. Y max, we will do 7,000. Since we're looking to be above 6,000, 7,000 just makes sense. So we'll hit graph, and then we can see our point of intersection. So now we just need to find that. So we'll get second trace, and we're going to look for the intersect. So first curve, good. Second curve, good. Guess, there we go. And this tells us that our point of intersection is at 2.09. So that's our answer. So in this case, x is going to equal, after we've done the graph, 2.09, or at least somewhere in that ballpark, because we found the point of intersection using our graphing calculator. So remember, we put it on the y equal screen, we put this, or y1. On y2, we put 6,000. Then we had to adjust our window, but then we found the point of intersection that way. The second method we're going to say is our table method. And we can use the table on the calculator, so we'll just go back to the calculator and start looking at those values as well. So to find the solution from a table, we'll hit second graph and go to the table. We're looking for values where it's going to be equal to 6,000. We have this other one in here, so we're not looking at that one so much. We're looking at the first blue y1 to see if we can find it where it's closer to 6,000. Well, it jumps here, so we can't see it. And we know that our answer is 2.09 or somewhere in that ballpark. So what we can do to get a better indicator of how our table should be counting, instead of here I have it counting by 0.5, let's go change our table setup. So second window, and we know that our answer is supposed to be 0.209, so let's just start at 2. And instead of being 0.5, we're going to go by 0.01. And so now we'll go back to our table, so second table. And now as we get closer, we're seeing that here we're pretty close. We're not perfect, but we're as close as we're going to get. We rounded our decimal, but this is where our solution would be. So you can find your answers from the graph or the table. I think the graphing method is a little bit easier, especially when you can adjust the window, but you could use the table as well. So using the table, remember you're going to have to adjust your table setup. You're maybe not going to be able to count by the same increments you did before, and you'll have to account for some rounding issues, but you should get a value pretty close, or at least see that value somewhere in your table. All right, so keep in mind, a logarithmic equation is an equation that includes one or more logarithms involving a variable. All right, so here we have, says, what is the solution to the log of 4x minus 3 equals 2? We're going to solve using exponents. The solve using the graph, you can handle that. You've seen how we solve the other problems, and we've had experience with solving graphically, so I'll leave that up to you. So in this problem, we've got log of 4x minus 3 equals 2. We're going to write this in exponential form, so that means we're going to take the fact that it's base 10, so it'll be 10 squared on this side equals 4x minus 3. And then we're just going to start to solve this. Well, 10 squared is 100 equals 4x minus 3. We'll add 3, so 4x equals 1 over 3. Then we're going to divide by 4. So in this case, x equals 25.75 roughly, or exactly. Here it says, what is the solution of the log of 3 minus 2x equals negative 1? So we've got log 3 minus 2x equals negative 1. Log base 10 here, so we're going to write this in exponential. So 3 minus 2x equals 10 to the negative first power. All right, and so now we can just begin to solve this. Well, 10 to the negative first power. 10 to the negative first power is just 0.1. So we've got 3 minus 2x equals 0.1. We'll subtract 3. So we've got 2.9 equals negative 2x. We'll divide by 2. And we get x equals 1.45. Oh, negative 1.45. There we go. Negative 1.45. There we go. Oh, oops, excuse me. It's not negative. Forgot I had to divide by negative 2. My bad. So your answer should be 1.45. There we go. So we subtracted the 3, got negative 2.9 divided by negative 2, and then you'll get negative 2.9 divided by negative 2 is just a positive 1.45. There we go. Here we're using logarithmic properties to solve an equation. It says, what is the solution to the log of x minus 3 plus the log of x equals 1? All right, so we got this addition here of logs, but we're going to use the product property of logarithms to rewrite this. So this would be the log of, in this case, x, well, let's put it like this, x minus 3 times x equals 1. What we can do is we can distribute this x to both of these. So that's the log of x squared minus 3x equals 1. So now what we can do is we can write this in exponential form. So x squared minus 3x equals 10 to the first. Well, 10 to the first is just 10. What we need to do now is we need to bring the 10 to the other side because clearly we're dealing with a quadratic. So x squared minus 3x minus 10 equals 0. At this point, we should recognize that we can factor this. Two numbers that multiply to be negative 10 but add to be negative 3. Well, that's negative 5 and positive 2. So in the end, our solutions here are x equals 5 and x equals negative 2. Because we have these two solutions, we're going to check for extraneous solutions in this case. So we're going to plug these back in and see which ones work. All right, so let's just start with the x equals 5. So that means we've got log of 5 minus 3 plus the log of 5 should equal 1. In this case, we're going to get the log of 2 plus the log of 5 equals 1. And in this case, log of 2 is like 0.3 and some change. The log of 5 is about 0.7. This equals 1, so 5 is good. We're good. Then we'll try x equals negative 2. And so the same idea, log of negative 2 minus 3 plus the log of negative 2 is supposed to equal 1. In this case, it does not. So this is our, so this doesn't work, so this is not a good solution. Let's try another one. What is the solution of log 6 minus the log 3x equals negative 2? So So for this one, we're going to use the quotient property of logarithms. So we've got log of 6 divided by 3x like this equals -2. We'll go ahead and write this in exponential. We've got 6 over 3x equals 10 to the -2nd power. All right, so we wrote it in exponential. So in this case, 10 to the -2nd power is 0.01. 6 divided by 3 is 2, so we can write this as 2 over x. And then we just need to solve this. So we'll go ahead and bring the x over, and we'll multiply it to the other side. So we've got 2 equals 0.01x. Then to get rid of the 0.01, we'll divide. And in this case, we get x to equal 200.